Good morning. In the last video lesson, we have seen this problem. Let us see once again. So, calculate the total electrical energy consumption and cost given the wattage, hours of operation, and electricity tariff. Okay. Now, here, first problem is a house has the following loads: 5 lamps of 60 watts each, working 8 hours a day; 4 lamps of 100 watts each, working for 5 hours a day; 2 heaters of 1000 watts each, working of 3 hours a day; 5 fans of 80 watts each, working for 12 hours a day. Calculate the monthly bill if the rate of charge is 50 pice per unit. Add 10 rupees as a meter rent per month. Now first let us calculate the wattage. Okay. So lamps, 5 lamps, 60 watts of each. So duration, that is total load is, and watts is 300 watts. So number of hours. Number of hours is 8 hours, working for 8 hours a day. So 8 into 300, 2400. So convert it into kilowatt hour. So by 1000, which is 2.4 kilowatt hours. So commercially kilowatt hour is known as 1 unit. Lamps, 4 lamps of 100 watts. So each working for 5 hours a day. So 4 into 100. So then you calculate total load. Total load is 4 lamps are there. Each rating is 100 watts. So 4 into 100, 400 watts is the total load in watts. And working for 5 hours. So into 5 gives you the wattage. And by 1000 gives you the kilowattage. Kilowatt hour. Okay. Similarly for heater also, for fan also. Then add all these. 2.4 plus 2 plus 6 plus 4.8, that is 15.2 total kilowatt hour per day. So for 30 days, 15.2 into 30, 456. So monthly bill is monthly kilowatt hour consumed into unit charge plus meter rent. So monthly kilowatt hour consumed is 456 into 0.5 plus 10. That is 238 rupees. Monthly electric bill is 238 rupees. Okay. Next problem. House has the following load. 10 lamps of 60 watts. The load is 600 watts. For 10 hours, for 10 hours a day into 10. That is wattage. Okay, 10 into 60 into 10. That is 6,000. By 1000 gives you kilowatt hour. Next, one electric iron, 450 watts. 1 into 450 into 1 hour a day. So that is 450 watts. Total load is 450 watts per hour by 1000 gives a kilowatt hour. 450 by 1000. So 0.45. Similarly, fans, 8 fans into 80. 640 is the load. And 12 hours a day, 640 into 12 gives you the wattage. 640 into 12 gives you wattage. By 1000 gives you the total energy consumed in the kilowatt hour. Similarly, one heater with the rating 1000 watts. So total load is 1000 watts for 1 hour a day. 1 into 1000 by 1000. This is watt hour. So that should be converted into kilowatt hour. So kilowatt hour is 1 unit. So it should be converted into kilowatt hour. So by 1000 gives you 1 kilowatt hour. Similarly, one refrigerator 250 watts. Load is 250 watts. It is working for 12 hours. 12 hours is 250 is 3000 watt hour. But 3000 by 1000 3 kilowatt. So add all this. So 6 plus 0.45 plus 7.68 plus 1 plus 3. That is 18.13 kilowatt hour. Total energy consumed per day. For 30 days, 30 into 18.13. That is 543.9 kilowatt hour, which is equal to 543.9 units. Cost per unit is 120. So into 120. And meter end is 20. Okay, so 543.9 into 1.20 plus 20, which is 672.68. So monthly electricity bill is 672 rupees 68 paise. Now you know that. Next. This is also a similar problem. 5 lights of 60 watts each working for 6 hours a day. The 2 fluorescent lamps of 125 watts each working for 3 hours per day. 5 lights of 60 watts means load is 5 into 60, 300. That is per day 6 in load is 1800. By 1000 gives you the kilowatt hour per day. Similarly, tube light, 2 fluorescent tubes, 125 watts, 2 into 125, 250, 250 into 3 hours, so 750. 750 by 1000 gives you 0.75. Next, heater, 1000 watts of one heater, working for 3 hours a day. So 3 into 1000, 3000. 3000 by 1000, 3. So this is the consumption per day. Total consumption is 1.8 plus 0.75 plus 3. That is the total energy consumed in kilowatt hour per day. That is 5.55 units. So September month is 30 days. So total energy consumed per 30 days is 5.55 into 30, 166.5 kilowatt hour. So 60 pies per unit. So 166.5 into 60 by 100, 99.9 rupees, and meter charge is 5 rupees. So 104.90 bucks. Next. Next, calculate the monthly electricity bill at the rate of 1.45 for the first 50 units, 2 rupees 80 paise for 51 to 100 units, 3.05 from this 101 to 200 units, 4.75 for 201 to 300 units, and 5.5 for the above 300 units for a residential building with the following loads. The rent and customer charges per month is 15 rupees. Okay. So as usual, calculate the load, then watt hour per day, then kilowatt hour per day, then total energy consumed per 22.178. So for 30 days, 665.34. So first 50 units 1.45, next 50 units 2.8, next 100 units 3.05, next 100 units 4.75. Remaining units, that is 200, 300, 365.34 is 5.55 plus 15 rupees. So that is comes around 3016.87 pies. So it's 90 pies. You can order. Next, a month of 30 days. Okay, similar problem. So here you can see that 4 lamps of 100 watts, 100 watts working for 6 hours. So 2 to 400. Immersion heater, one immersion heater, 2000 watts, 2000 watts for 1 hour. So 2000 is the total energy watt hour. Next to fans, 3 fans of 60 watts, so 180 into 10 hours, working for 10 hours a day, 180 into 10, 1800. Electric iron one of 1000 wattage for 1 hour, so 1000 watt hour. So total energy in watt hour is 7200 watts. 7200 watts by 1000 gives you kilowatt hour. So 7.2 kilowatt hour, that is 7.2 watts, sorry, units. So total energy consumption per month is 30 into 7.2 to 16 units. So 216 into 50 pies, that is 108 rupees. Next, merits of CFL lamps over incandescent lamps. That is, compact fluorescent lamp gives the same amount of light as compared to the incandescent lamp. But power consumption is low, typically 1/5 of that consumed by incandescent lamp. Longer rated life, 6 to 10 times than incandescent lamp. Okay. Merits of LED lamps over compact fluorescent lamps, CFL lamps. The LED lamps having the following merits: less power consumption, more light output, long lifetime, no wastage of light, high efficiency. Unlike CFL turns on instantly. No warm-up period, that is. No heat produced. A low voltage power supply is sufficient for LED illumination. Mercury free, high durability. Okay. So these are the advantages. And then done. Next. Next, define thermal efficiency. It is defined as the ratio of heat actually utilized to the total heat produced electrically. Okay. Thermal efficiency is heat utilized by heat produced. Heat produced is VIT by J. Heat utilized is ms into theta 2 minus theta 1 calories. M is the mass of the water in grams. S is the specific heat of water. Theta 2 minus theta 1 is rise or change in temperature in degrees centigrade. So you just note down this definition, that is sufficient for you. Heat utilized by heat producer gives you thermal efficiency. Next, the practical appliances of electric heating. Electric kettle, electric cooker, electric iron, space heater, geyser, electric water heater, geyser, infrared lamp. So first one is electric iron. It is used to press the cloths, that is to remove the wrinkles and creases. Works on the principle of heating effect of electric current. Okay. So what is the working principle of electric current? That is, when current is passed through a coil, the coil gets red hot and transfers the heat to the base plate of the electric iron through conduction. That is the principle of electric iron. Okay. There are two types of electric irons, non-automatic electric iron and automatic electric iron. Parts of non-automatic electric iron. There are three main parts, working parts in either automatic or non-automatic electric iron: base plate, pressure plate, and heating plate. The remaining plates are cover plate and handle, etc. Remaining parts of iron ore. So the base plate is or sole plate. Base plate or sole plate is the first part on the assembly line. Okay, this is the base or sole plate. It receives the heat from the heating element and use it to press the clothes. This base plate is used to press the clothes. It receives the heat from the heating element. Pressure plate, that is weight plate. Weight plate. This is generally called the top plate and it follows the shape of the sole plate. Okay, it follows the shape of the sole plate. Its size is bigger than the heating element but smaller than the sole plate. It is made up of cast iron and keeps the heating element in its position. The pressure plate has some holes through which the studs, these are the holes, through which the studs from the base plate passes. Okay. Next, heating element. This is the heating element. Okay, it consists of nichrome wire wound around a sheet of mica. The heating element is placed above the base plate. The heating element is present between the base plate and the pressure plate. The two ends of the nichrome wire connected to the contact strips. The contact strips are connected to the terminals of the iron. Okay. Next, cover plate. Cover plate is made up of thin sheet of iron. It covers all the internal parts of the iron. Handle, this is handle. It is made up of either wood or ebonite. It is attached to the cover with the help of screws. So this is the complete electric iron. Now you can see the complete electric iron parts. So this is the assembly of electric iron. Working. The combination of heat and pressure removes wrinkles. When a current is passed through the heating element, which is placed between the base plate and pressure plate, the elements get heated up and transfers the heat to the sole plate. Through the conduction, and in turn sole plate also gets heated up. It is a heating effect only. Now to remove the wrinkles in clothing, we should apply heat and pressure. Heat is formed to the coil and when we press the clothes with iron, the wrinkles are removed. This is the working of electric iron. Note that. So these are the practical appliances using electric heating. The effect of electric heating. Next. Okay. We'll continue in the next video lesson.